All right, here we go. We are still on lesson, well, don't go too far. We are still on practice 532. We're now just, we did the first three problems. Now we're looking at number 4. Okay, so number 4, all right. Identify the similar triangles. Find x and the measure of the indicated sides. Okay, so this is where I want to actually switch it up and go ahead and do this problem with you. So let me get that going. Square. All right, so let's go ahead and share that. And bingo. All right, let's see. And I need to be able to go back and forth because I don't recall. All right, let me go ahead and draw this out. This is number 4. And we have this triangle here. It looks like we have 1 tick mark, 2 tick marks for that angle. This is 2, A, B, C, that's 3. Okay, and then we have this triangle over here, 2 tick marks, 1 tick mark. We're calling this X, we're calling that 5, Y, X, Z. All right, so let's see. We are looking at these 2 triangles, and there's going to be a process for this, okay? So this is where we get into my processes, which might help you, okay? So really what we know is this side is 3, okay? We have 2, this side is, we're calling this X, which is confusing because it's also angle X. This is X, and that's 5, okay? So first off, we know that these 2 triangles are similar, right? Similar, which is just one of these, kind of like congruent has a squiggle over the equal sign. This is taking the equal sign out, and you have similar. Okay, so we know these are similar from angle, angle. We have an angle here and there; those are the same. Double tick mark, we know those are the same. So because they're similar, now we want to find what X is. Now, what side does X correspond to in this triangle? So I look to see, okay, this side X is between 1 angle tick mark and 2 angle tick marks. I use that to kind of navigate, okay? So this side right here is corresponding to 1 tick mark, 2 tick marks. The side over here, it corresponds to 2. So I like to make a little line to it like that. And then I look over here, let's see, 5. The side that is 5 is across from the double tick mark. That will always be a good way to guide as well. Double tick mark, the side across from it, just like it's across here, is 3. And we know that these similar triangles have these sides in common, okay? Now, this is where we are gonna make a ratio, okay? So let's make a ratio right here. And you're like, ratios, but actually this is gonna be pretty straightforward, okay? The way you have to do this is you always have to have one ratio relating the sides, and you gotta keep it like in the same order. So watch. I'm gonna go this triangle and then this triangle every single time. This triangle and this triangle. So watch. This ratio is gonna be relation between 2 of the sides, 3, going from this triangle, 3, to that is 5. Okay, so we have 3 and we have 5. Now, that's great. We have to now relate this, but which one do we put on top? Okay, because I know I'm gonna relate X and 2. Do I put X and 2 like that? No. Just always be consistent. If you're like, well, I'm not sure which one to put, well, follow the same pattern as before. This ratio right here, 3/5, took this triangle first and created a ratio with the corresponding part over here. So we're gonna do the same thing. Take this triangle first, 2, corresponding to the side over here, X, and now we have a ratio that we can use cross multiplication and solve. So now we have 3/5 is equal to 2x, right? Cross multiply, 3x is equal to 10, divide by 3, and we get this x side is 3.3 repeating, okay? So that is how we're gonna approach any kind of triangle that we can distinguish as similar. If we can distinguish it as the similar triangles, then the sides correspond. Okay, that's the main thing, the sides correspond with this. Okay, let's look at another example problem. I think that actually is pretty helpful to break it down like that. Let's see. Now we have a more complex problem. So this is great. This is number 5. And it looks like we have this triangle, A, D, E. We got 1 tick mark, we got 7. We have X plus 2, which is probably freaking some people out. Don't worry about it. We have 30, 35. You just have to be careful. I mean, it's just drawing. You just have to, carefully go through and make sure you get everything right. And you're like, that's too much to write. You all doing 20-page essays in college, talking about this is going to be too much. You got to get used to that. All right. So this is C. That did take a while, but whatever. All right. So let's look first. First off, are these triangles similar? So far, all we know so far is that we can use angle, angle to show them similar. So let's see if we have that criterion. Let's see. Well, we have these angles, angle E and B, and angle E these almost look like right triangle angles or not. That's that angle, and that's that angle. So we have two angles in common, or one pair of angle. Then we have this 35 and this 35. We have this 30 and this 30. So we've extended beyond what we needed to find two angles in common. We found three, and again, if you have angle, angle, you always have angle, angle, angle. But we don't need to prove angle, angle, angle. Uh-oh. It is frozen. Let me try to stop share again. All right, come back. Come back, please. Now it's just showing my phone. Oh my, what is that? Okay, we're back. All right, angle, angle is angle, angle, angle. Because remember, there's three angles in a triangle. So if two are in common, the third must also be similar, must also be congruent to the other triangle. So we know that, yes, these are similar by angle, angle, so we can do what we did before. Now, we're gonna relate two sides here. I'm gonna start with the smaller triangle, 3.5. Let's see, where does that fit? It fits between 1 tick mark and 3 tick marks. 1 tick mark, 3 tick marks, 7. And so I'm gonna carefully make a line to that, okay? What is next? Next we have x plus 2, and that's between 35 and 1 tick mark. 35, 1 tick mark, obviously it's gonna be that one, okay? So we have our sides related, our corresponding sides. So it's gonna be kind of tricky. Where do I write this? I'm gonna write it right here, okay? So what we're gonna do is we're gonna relate 3.5 to 7, right? This triangle to this triangle. So let's do the same order, this triangle to this triangle for the other side that we're comparing, okay? It's just a matter of making sure, because what if I put x plus 2 on the top and 7 minus x on the bottom? It's gonna mess things up. So look, the reason I put 7 minus x on the top is because I put 3.5 on the top. 3.5 is a part of this triangle. So I'm doing the relationship between this side and this side in the same way that I set up this side and this side. So always relating it as far as like, how do you know what goes on top? The values from the same triangle go on top, the values from the same triangle go on the bottom. Each ratio compares corresponding sides. We got to just make sure that we get where we're getting the information from. We got to make sure we're solid with that. Okay, here's the thing. 3.5 over 7 is, 3.5 is half of 7. So I can automatically say, well, this is 1/2 is equal to 7 minus x and x over x plus 2. Okay, I'm gonna bring that down here. And now we cross multiply. 1 times x plus 2, x plus 2. 2 times 7 minus x is gonna be 14 minus 2x. Let's go ahead and add this 2x over here. Oh, it's gonna get close. Let's see if I can do it. Let's minus the 2 over to the other side. When you add 2x to x, you get 3x is equal to, if you minus 2 from 12, you get, if you minus 2 from 14, you get 12. Divide by 3, divide by 3. X equals 4. Wow, just had enough room. X equals 4, okay? So x equals 4. Let's see if that works. X plus 2 is 6. 7 minus 4, what? Wait one sec. X plus 2 is equal to 6. Uh-oh, we have a problem. Let me see what happened here. I'm gonna pause it and just double check because that should be the exact same length. No, it shouldn't. All right, got it. So think about it like this. Remember that our sides, this was twice as big as that one, right? 7 is twice as big as 3.5. So I was a little confused. I'll just bring it back. Forget what I just said. X plus 2, this side is larger than 7 minus x. So when I plug in 4, we're not going to get the same length for the sides, right? X plus 2, this is going to be 6. 7 minus 4, this is going to be 3. Hey, that makes sense. If this side is 3 and this side is 6, that's twice as big. 3.5, twice as big. 7. We got it. All right, so we got it. And I think actually that one is the last problem. Yeah, we're gonna go ahead and we're gonna go ahead and stop there and work on some other problems. So we'll stop recording. Watch the next one.